If you are looking for a solution to keep track of remote measuring stations that are geographically dispersed, where most of the time nobody is out there is no connection to the electricity grid, and no wired connection can be established, Remote Terminal Unit or RTU is your best choice. An RTU is sometimes referred to by other terms, such as Remote Telemetry Unit or Remote Telecontrol Unit. An RTU is a rugged standalone microprocessor-based electronic control device deployed in an industrial environment at specific locations, which informs plant operators about what's going on out there all the time. It is intelligent and complex enough to automate a process with field equipment without needing input from a master controller. The gear that makes up the backbone of your industrial network will often report issues immediately when measured values fall below or exceed a predefined threshold. An RTU enables the reliable monitoring of digital and analog parameters of various field equipment you have at remote sites. It acts as a local connection point to gather and collect measured data and information from connected sensors. The RTU performs data processing on the aggregated data, and as a result, the received raw data is scaled and translated into a transmittable format. One way to achieve converted data from RTU is through the web interface via PC. Here, not only you can access all events happening to your ongoing process, but also control the entire system with a simple mouse click and minimize a multi-hour trip to the remote location. Also, you can use the web interface to set up settings on how the RTU can contact you when transferring data is going to happen. For example, in the event of a failure, the service staff may receive automatic phone calls, SMS text messages, or emails that outline the alarm situation in detail so they can solve the issue. When the number of RTUs increases, using web interfaces to check the whole system no longer makes sense, and in this case, it is preferable to have a central master station. Here, RTUs establish interfaces between field instruments in physical processes and the automation control system. To do this, RTUs share the collected data from field devices with the master control station via a communication network, and for that, RTUs use either a secure wireless network or cables connected to communication channel interfaces in a wired network. After communication channels have been established, RTUs use a protocol such as DNP3, Modbus, and SMP to transmit status data. Once the control station receives data from the entire fleet of RTUs, it brings all information together and presents a detailed description of what's going on at each site in a single easy-to-use interface. You can use the dashboard to take appropriate actions based on the existing alarm situation on industrial sites and start sending control commands over the communication network to RTUs. Then, remote terminal units will deliver command signals to field equipment to control functions and physical states of actuators, and as a result, fix the issues of local processes. Now, let us talk about the main components of an RTU, which include the power source, central processing unit or CPU, discrete inputs, analog inputs, control relay outputs, and communication interface, which can be a port or an external antenna. We will cover each of these components in further detail. When it comes to the power source, the RTU has a flexible concept. The RTU is self-sufficient in terms of energy due to the usage of a battery module or an accumulator with a solar panel. Also, the RTU can use a DC standard power supply as a primary power source, which converts the AC input voltage to the DC output voltage. The power source must guarantee that RTU receives constant power so local processes can continue their automated procedures. Next, we've got the CPU, which is the system brain and runs the processing of the primary function. Nowadays, RTU built-in central processing unit employs a 16-bit or 32-bit microprocessor. CPUs used commonly within RTUs have a memory capacity of 256 kilobytes. Because of this, some RTUs support using the SD card to provide additional storage capacity. Next, we check the discrete input section. This component is used to acquire states of discrete parameters locally from field devices that only have two statuses. These devices are either completely on or completely off, such as a proximity sensor. Next, we'll consider the analog input section. This component is used to acquire values of continuous parameters locally from field devices that have a range of values. The applied analog input is often a variable current or voltage that varies in direct proportion to the sensor measuring values, which is then converted into usable data to be processed. Next, we examine the control relay output section. This component is used to send electrical signals and commands to switch power on and off to discrete actuators in the field to have control over them. And also, let us explore the communication interface section. The RTU is equipped with this component to interface with the master control station through wireless or connect to multiple electronic devices within the network to share information and data. Finally, let us compare RTUs with PLCs because although they share many common characteristics, there are some dividing lines. RTUs can be deployed routinely in long-distance outdoor locations that are difficult to access, where getting reliable data would be both critical and challenging. While PLCs are ideal for managing local areas such as production lines and plants that rely on physical media for control. RTUs and PLCs can both support various types of inputs and outputs, but we begin to notice differences in the capacity. Typically, RTUs tend to have more I/Os than PLCs. One of the significant benefits of RTUs is environmental tolerances. RTUs have a rugged construction and are specifically designed to survive in harsh conditions. They can operate reliably in environments with extreme temperatures and relative humidity of non-condensing. They can also withstand power surges and have protection over vibration, dust, rain, and fog. Unlike RTUs, PLCs can withstand harsh environments and we can't rely on them to get data in these specific situations. Typically, PLCs are smaller than RTUs because RTUs have more I/Os and have a rugged and durable design that takes more space. Also, because of these reasons, on average, RTUs are more costly than PLCs. Compared to PLCs, RTUs consume less power because RTUs put energy-saving measures in place and are usually found in the so-called sleep bank. It means RTUs switch from sleep mode to update mode when they want to acquire data from field devices, or they remain in sleep mode until they need to establish communication with the master controller to send information. On the other hand, PLCs are constantly in communication with field devices to send and receive data to monitor and control processes where speed and accuracy are crucial. In the case of power source failure, RTUs can still have autonomous operations thanks to flexible and freely combinable power supply options. In this case, RTUs can supply themselves from redundant and backup battery modules, use an accumulator with a solar panel as an alternate power source, or employ a DC power source with battery backup to ensure uninterrupted operations of RTUs. If the power source failure happens for PLCs, they can supply themselves from UPS units as backup power supplies to continue operation. An RTU may include a single complicated circuit card with numerous sections required to perform a custom-fitted function, or it can be customized and expanded by adding various types of circuit cards. This feature can be extended to the PLC as well, and the PLC can be used as a compact model or a modular type to monitor and control local processes. RTUs don't need to be programmed from the ground up. They have built-in capabilities that can be configured easily through a web interface without using additional software. Here, you can configure all necessary parameters such as labeling all inputs and outputs and setting up rules for control responses to sensor inputs upon exceeding preset threshold values. Since you don't write codes from scratch, you don't have much freedom to write complex control responses for complicated processes, and that's why just a few automation functions are supported by RTUs. On the other hand, PLCs need particular software and specific skills of different PLC programming languages to write codes for any functions from simple to advanced logic, but have to do it from scratch and program everything.